Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will show you how to use Excel to construct two types of confidence intervals, dependent on what type of data you're given. And this video assumes that you know the main terminology when it comes to this topic, so you know what a confidence interval is, how to construct it by hand, and how to interpret it. Okay, this file will be available for you to download. You will need to go to your Blackboard site, go to the folder associated with Chapter 8, and then this file should be there. So let's go ahead and take a look at a problem from your homework. I'm looking at problem 7 in section 8.2, and we have the average selling price of a smartphone purchased by a random sample of 43 customers, and that price was $316. Assume the population standard deviation was $31. We're asked to construct a 95% confidence interval. So if we go back to our Excel file, here I'm giving you a formula, just a reminder how to construct a confidence interval if sigma is given to us. So it is sample mean plus or minus z of alpha over 2 times the standard error. So that's something very similar that we've already done when we were asked to construct a symmetric interval that contains, let's say, 95% of the middle data, right? So this should look familiar. Okay, over here, I've already created some commands that will let you do these computations very quickly. And all you need to do is just plug in numbers in these blue shaded cells. So let's go back to our problem and see what we have. The sample mean was $316 with a standard population standard deviation 31, right? So 316, 31, and the sample size is 43, which is great, because we want this number to be bigger than 30, so we can apply the central limit theorem. Confidence level, in my case it's 0.95, okay, and the next cell will compute the z of alpha over 2 value that's associated with this level. And let me show you what this command is doing. I'm using the inverse normal command, and I'm doing 1 minus this value right here, divide by 2, standard normal parameters. But since it's going to compute the value to the left of 0, I need to multiply it by -1, so it makes it the positive z-score. Okay, so that's what I did over here. And then the next two commands will pretty much use this formula right here, these two formulas, to compute the upper and lower confidence limits. Okay, so if you actually click on the cells, you'll see exactly what's going on. This is your sample mean minus the z value times the standard error. Okay, so let's see if that's correct. We're going to go back here and say the lower limit was 306.73. And then the upper limit is what? 325.27. Okay, that's correct. What is the margin of error? Okay, what is the margin of error? So it's actually asking us to find what? So the margin of error would be the z value times the standard error. So you can compute it real quick. So what is this? So that would be this times the standard error, which is the population standard deviation, divide by the square root of, in my case, it's 43, right? Okay, so mine is 9.27. All right, and you can notice that this is the value, oops, let's go back. Okay, this is the value that would be exactly half of the length of the interval, right? So it's x bar sample mean plus this value, and x bar minus this, that would be 306.73. Okay, so that is your margin of error. So let's just say I wanted to write an interpretation. This problem right here is not asking you to write an interpretation, but let's say we were to do it. So what would be the interpretation for this problem? Okay, I would say we are 95% confident that the true population mean price for smartphones is between what? Okay, so if we were to do dollars, 306.73 and 325.27. Okay, so we're making an inference about the population mean price. Okay, we took a sample of 43 purchases and found the sample mean, which was 316. It's very unlikely that the true population mean price is actually 316. Okay, so we want to give it a little bit more of a range, and that would be this statement right here. Okay, so this is your interpretation in the context of the problem of what this confidence interval actually tells us. Okay, we are 95% confident that the true population mean price for smartphones is somewhere between these two values. Okay, so that's how you would use this setup right here to construct a confidence interval if sigma, the population standard deviation, is given. Okay, now in real life it is highly unlikely that we actually know sigma. If we know sigma, it is very likely we know the population mean. So most of the time we should be able to use something different. Okay, so when sigma is not known, we are going to be using t-interval. Okay, and t stands for student's t-distribution, which is very similar to normal distribution, but not quite the same thing. Hello everybody, and welcome back to Business Statistics Online. This is the second part of the video where I talk about Excel and how to use it to construct confidence intervals. So in the first part we talked about z-interval, where we're given sigma and how to do computations for this type of problem. Now let's take a look at a problem from section 8.3, and I'm using problem 8. Okay, so let's see what we have here. We have a random sample of 15 college men's basketball games during the last season, and the average attendance for these games was 5,112 people, with the sample standard deviation of 1797. Okay, and they would like for us to construct an 80% confidence interval to estimate the average attendance of these basketball games. So when we're not given sigma, the population standard deviation, we can no longer use normal distribution. What we'll be using is student's t-distribution, okay, which is very similar to normal in shape, but not quite the same. It's a little bit more narrow, and it depends on the degrees of freedom, which also depends on sample size. Okay, so this file right here is already set up for you guys to use, just like the one before where I set up the normal distribution. Here I have a slightly different set of commands, but let's see what we would do here. Okay, I have my sample mean 5112, right? So that's what's gonna go in sample mean 5112. I no longer have sigma, I have S, which stands for sample standard deviation, and in my case it's 1797. The sample size is 15, and the confidence level in my case is 80%, so 0.8. So what this command is doing, it's actually computing it of t of alpha over 2, very similar like we've done with inverse normal, but here we use the t inverse command, and that depends on the alpha level, which is 1 minus this. So alpha level in our case is 0.2, and the degrees of freedom go in the second part, and that would be the sample size minus 1. Okay, so all of that is already built in this formula right here. And then lower and upper limits computed according to these two formulas. Okay, so now that we have that done, we can go ahead and plug in our numbers. They want us to round to the nearest whole number, so that would be 44.88 for the lower limit, 57.36 for the upper. Let me just double check. 44.88, 57.36. That looks good. And that's correct. Okay. What assumption do we need to make about this population? Now let's take a look at a sample. The sample is actually kind of small. It's 15. It is less than 30. So we must assume that the population follows the normal distribution. Okay? So we're going to go ahead and say D. Let's check. And that is correct. Okay? So let me go back here. If we were to write the interpretation, what would I say? I would say we are 95%, oh, not 95, 80% confident that the true average number of people attending these basketball games is between 44.88 and 57.36. Okay, that's what you would say over here, just like we've done for the previous example, where 95% confident that the true population mean price was in between those values. Very similar setup here, just change your wording according to the context of the problem. Okay, so I think that's it. We'll stop right here. Thank you for watching.